I'm going to firstly thank you for the opportunity of speaking at this great forum. I've been a member of the PDY for about 23 years, and I've been to a couple of these events, probably not as many as I should go to, so there's a lesson there for myself. But reflecting that I go to ICE, IMECI, conferences of this nature, this is probably one I've seen the most attended. So I think to the PDY, to see how it's grown over the last number of years with the leadership, I think is actually a great statement. And for me, go to ICE, IMECI conferences, I don't see this many people there. So a level of congratulations to the group who pulled this forward. A little bit about myself. Briefly, I am currently the global high-speed rail leader for Arup. I'm a director within the company. I've been there for about 18 months now, and more recently I've become the rail business leader. So another level of apology is today I've seen some fantastic presentations, lots of technical detail, lots of graphs. My next 20, 30 minutes is not really a technical presentation back to you, so apologies if you're expecting a future rail presentation with fancy slides and what the future rail will really look like. It's probably going to be more a bit of a philosophical view of where I see rail. From our position within Arup as a director, I have an opportunity to see the global rail market, and I have done for the last 18 months, and seeing where rail is taking us. And actually within the UK, where the rail is going to take us in the next number of years, some great opportunities. So probably a little bit more philosophical, a bit of reflection on what we've seen today. Certainly in terms of what's been presented, this might even be a summing up, I guess, because we've heard today about common themes in monitoring and how we can monitor what our asset is doing from the S&C side, looking at increase in tonnage that we are seeing on the railway and how that affects our asset and our infrastructure that we all design, maintain and look after, data management, alternative materials, and finally picked up from Pandrel, the noise issue. And the noise issue is one I'll come on to a little bit later on in my slide. So hopefully this will be of interest, but probably more importantly, it'll probably sum up some of the things we've seen today and actually some of the challenges the railway industry faces. Is this working? Gone. Right, sorry. I'll learn to use technology next. So what are we going to look at? So in 30 minutes, or hopefully within 30 minutes, what are the challenges the railway engineers face? A bit of a societal view, because railways is a societal opportunity for moving people and freight around. So how does that affect us as railway engineers? Some of the future design factors and considerations that we as engineers and people in the industry need to take into consideration now, and we are. Actually, what does that mean for us in the future? Some of the emerging technology areas that I'm seeing come into fruition and we'll see to come to fruition in the future. Some of these may be seen as a little bit really blue sky thinking, but how technology has changed in the last 5 years just demonstrates how things are going to move forward in the transport industry fully. Technology, the opportunity for change, and then finally legacy. Legacy is something I think sometimes is omitted. What is the legacy of what we design? What is the legacy of what we install? And how is that looked after? Because effectively, that's how people judge us. So what are the challenges the railway engineers face, the societal view? And this is a more broader view. So that is Shanghai 1990, Shanghai 2010. And it's quite clear that megacities are growing. And there's this trend that I'm seeing from my trips around the globe and around the UK, that megacities is a word that people use a lot of. And there's people in the railway industry, they want to move people from point A to point B, and megacities are things that are growing more and more. About 2-3 months ago, there was a conference here in Manchester, not far from where we are today, and Andy Burnham, the Metro Mayor for Manchester, was there talking about Manchester, the great city. And he gave me a fact that I hadn't really reflected on. If you look at Manchester today, there's probably more tower cranes per square foot than there is in London. And that just demonstrates how Manchester and the cities around the UK are growing and will continue to grow. So projects such as HS2 that we've heard mentioned today, and we will continue to hear mentioned over the coming years, are going to change how our cities grow. And from a transport perspective and from a rail perspective, it will dictate how we deliver and how we make people move around these great cities, be it in locations such as Shanghai or Manchester, Liverpool, London. And therefore, rail has a significant part to play in that. And as railway engineers, how do you engage in that and how do we understand how that is going to interact? Because public transport will become more and more of a key action that governments want within the UK and within the globe. So the move from road to rail to other forms of transport systems, but rail in particular, is the one that governments are going to put more and more pressure on. And there's a comment mentioned by one of the presenters this morning about will the UK see more new railways built? And my comment back to that is yes, it will. And my other comment about it, globally, we're going to see more and more people wanting new railway lines, be it for freight, for light rail, or heavy rail, seen across our globe. And as a railway group and railway experts in the track side, this is something where you as a PDRI and us as members will have far more influence in how that takes us forward. And reflecting on the UK, we mentioned HS2, but only last week I was talking to Simon Blanchflower, who's now looking after East West Rail. That's another scheme that will, over the next 4 or 5 years, start to take greater shape in linking Cambridge with Oxford, and it'll be a new railway line. And how does that influence the operational network? How does the track system work in that? Is something actually Simon is very keen on. It's not a fast railway line, it's 100 miles an hour. But he is actually after systems that will allow him to operate that network efficiently, on time, and with easy maintainability and accessibility. Well, what are the challenges the rail engineer faces in the UK? So this is one of the graphs, and probably the only one graphs we're going to talk through. That's from an ORR report, and what it clearly shows is passenger demand on the railway system is growing, and since 1994 it is steadily growing, and it's going to continue to steadily grow because people want to use the railways, whether to move freight or more importantly to move people. And as we've seen with the debates and the views of HS2 as a project and other projects that have been put on the UK financial line, there is a demand for putting more railways into our system, be it upgrading existing networks, undoing what Beeching did 20 or 30 years ago, or creating brand new railway lines or freight lines to allow the country to grow economically and to deliver what it needs to do. So demand is going to grow, capacity, as we know, is reducing, and that has an effect on this. So from a network perspective, it means we're getting reduced access. So I hear from conversations after Convex Network Rail, there's further reduction in access because you need to run more services, you need to run more tonnage. It's a major issue. And that then has impacts on resilience and performance. So how do you design a piece of track infrastructure that has greater resilience, has greater performance to deliver what effectively the customer wants? And sometimes now, being an engineer, on this side of the fence, what does a customer need? Why does a customer want that? Which then drives to requirements, improved components, and we've heard a lot about improvement components, and this morning's presentation on the S&C and being able to monitor what S&C is doing and tell you over your phone it's about to crack. That is an incredible move in technology as to how we can understand what our components and asset is doing, and therefore be more resilient. But sustainable and environmental solutions, I'll come on to that a little bit more, but effectively the sustainability debate that I see both within the UK, globally and within certain political parties is a bigger issue. So how do we create a sustainable railway? How do we use materials that we take out of our asset and reuse them? How do we actually make the materials we've got available to us more efficient so actually we are being a more sustainable solution? And how does rail system solutions evolve? So I start looking at schemes that as Arup we've done, or accessibility Arup schemes that we've done, and look at the challenges we face. So this is Kentish Town Track Slab. I am not in any shape or form going to go through the technical details of the scheme. It's far beyond my technical capability now. But to me, it reflected an issue that the UK faces, and as track engineers and track designers and maintainers, it's something that we're going to see more and more of, in my opinion. The asset is old, it's Victorian in places, and it has been renewed and needs to be further renewed. And Kentish Town example were a complicated piece of network, required a change to a part of the system because it was the old track packed system, had to be removed, and there was limited time to do it. So how do you do it in a 10-day blockade in 2017? Because actually Christmas was the only time in which you could get in there. But from the client perspective, how do you ensure that what you design and what we design and what the contractor installs is actually fit for purpose and actually is going to give the answer the client ultimately wants? Because effectively, once it's in and it's installed, then that's it, it's in and installed, and you're going to get very limited access to go back and review it. So a lot of finite element analysis, discussions with Peter Woodward this morning and other people presented about how we've looked at the design, how we've analysed design, how the design is going to react on certain types of loadings. And that, to me, is part of the future. And it's not about how we maybe get to the stage of how we install the infrastructure, actually doing more upfront analysis and examination of how these components are going to react in a situation over a 10, 20, 30-year period, reflecting on how tonnages of trains are going to change, how trains are going to react over this area. It's going to become more critical to us. So as engineers, the future is looking at how is this going to behave, and giving some certainty to the client that actually once we've designed this piece of installation, whatever the installation may be, in this case it was there's Pile Foundation Solutions, is it going to actually deliver what the client wants? And actually as a system, is it going to deliver the output that the country demands, not just the client being Network Rail? We mentioned this previously on the panel about noise. So on the left are two articles, one from BBC Radio 4 and one was a local newspaper. I think it was one of the Children's Guardian magazines. And yes, it reflects the high speed too. But to me, it puts a serious question to people that we deal in the rail industry. Noise is a big issue. Depending on the track system you use, so on the right-hand side, you've got the typical track systems from a ballasted system or directly fastened system all the way through the various booted sleepers, floating track slab with discrete supports, all manner of systems that you all know, you all use, you all design in your various projects. And the challenge is, how do they react to noise? Because effectively, from the other side of the fence, the public side of the fence, they want railway lines, be it high-speed rail or conventional speed rail, but what they don't want is they don't want intervention. So as a railway system, we talk about working with our signal engineer colleagues and our overhead line engineering colleagues and the colleagues who we know within our fence lines, because this is a railway system. Actually, what I'm seeing more about now is how do we actually deal with the other parts, the noise and the vibration side, because effectively this is just as important to once a piece of system is built to ensure that actually our clients and our users are happy with the end use. And the last thing you want is to have someone complaining daily that they don't like the noise. So noise barriers, things you may have seen on the news about how you mitigate noise is a big challenge and a big question, but actually from a track system, and I think it was mentioned by the panel presentation, is how do you design a system that actually starts to mitigate the noise at the source, as well as putting barriers and other sources of solution in its place. Another challenge I feel railway facing is in terms of routes. There are more and more countries want railway lines to go into their inner cities, which means 9 times out of 10 you're going to have to put it in a tunnel. If you take Manchester as a prime example, HS2 is going to tunnel its way into Manchester up towards Manchester Piccadilly. This is a location out in America, but effectively that tunnel will pass under some quite sensitive buildings. I think one of the HS2 routes originally passed under one of the major hospitals in Manchester. It therefore has issues about resilience and sound and vibration. And where does a track engineer sit in that equation early on, not at the grip stage 4 or grip stage 5 design stage, actually in the grip stage 1 to 3 stage, saying, actually, what systems can I put in place to mitigate any level of vibration or any level of impact on the system? Not just from the tunnel and the tunnel boring machine that everyone has to go through to get these things in place, but actually, how do I miss some of these obstacles? How do I get close to the foundations of quite sensitive buildings, but mitigate the noise and vibration? Singapore Circle Line is a scheme that we've been working on for a while. Again, 2 graphs, but I'm not going to go into them because, again, it's beyond my technology at this point or my capability. But the challenge is, how do we thread railway lines through sensitive buildings and sensitive structures and ensure that those people who sit in their offices do not know you're there? So an example that I've not got a slide for, apologies, it was Bank in London and I can't remember which underground tube station it is. Tube line is. I think it's Victoria. It passes very close to a number of high-profile banking companies. And the thing was built, and the train started to run, and the very well-paid bankers suddenly started to get a bit upset because they could hear the trains running underneath them. And no one had taken into consideration, actually, the vibration and noise that these trains take every 30 seconds to a minute, so this was a constant issue. The challenge was then to go and monitor it, understand what that was, and then with the baseplate manufacturer to put in a different baseplate system to try and mitigate that noise and that vibration. And actually, through working with a component manufacturer, through working with some sound experts and some people who understand how foundations actually react to train movement, they were able to cut the noise down. But that should have been reflected well before the design was completed. So as a railway engineer, understanding where your track and your system is going to go and how that can implicate and impact on the surrounding area is an area that I think we're starting to explore, but I think we'll start to explore it in a lot more detail as our clients dictate far more from us. Formations, variation, depth and predicted tonnage. So this was a piece of work that was undertaken in Turkey. And the challenge was that the client wanted to limit the amount of ballast he could put in under his track to keep some cost elements down, but also in terms of the formation that was there. So some examination was done with a local university in terms of understanding the impact of different trains, different speeds, and different impacts of resilience. The overall objective that was mentioned in some of the slides earlier on today was effectively by understanding how the reaction of the formation and the subformation work, and by understanding the tonnage of the trains that you're going to put on the network, you can start to have a better view actually how much ballast and how much infrastructure do you need to put in place. But this isn't something you should do using network rail terminology at grip 4, grip 5. This is something you need to do probably around by grip 1 or grip 2, because you need to be able to design what is the right solution and how is this going to impact my delivery. So, future design factors are reflecting that track is part of a wider system. And it is, and it's not just about the overhead line or the signalling or the power. As mentioned before, it's as much about the noise and the vibration side and the external impacts that our track design has. So, resilience. Now, that picture up there is from New York. Hurricane, I forget what the hurricane was called now, 3 or 4 years ago when New York got flooded. But to me, it's a general question, how well do we design resilience into our track design system? Because effectively, as these mega cities grow and the rail system becomes more and more critical for the movement of people on a day-by-day basis, suddenly having something that actually wipes it out because of natural disaster causes major problems. And you see the press articles, you see the challenges from politicians and people who don't understand rail engineering in any shape or form, but they challenge why is this allowed to happen. So the question really from the future and looking at the future of rail design is how does resilience factor into your examination of the work that we look at? Some examples from this morning were really great in terms of how do you design resilience into your S&C. How do you start to understand what S&C is doing under certain tonnages and loadings, and actually how can you react to it? And having that data to hand and being able to manage that data is extremely important. The nervousness I have is that we monitor so much, do we know what we're monitoring, why we're monitoring, and what we're going to get out of that monitoring? And in discussions with colleagues in NR and other asset owners, there's an ability to gather terabytes, billions of terabytes of data, but what do you do with it on a day-by-day and be able to make influential and strategic decisions on what your asset is doing. The virtual world, see before you buy. This is really something we're seeing more in the building industry, see stations, but I actually think it has a significant component within the railway design. How do you know what you're designing? How is it going to fit into the environment? And we saw earlier on from Salford University, how can you physically model how railways are going to be built? I think that's an incredible tool, which actually should be presented up to some of the non-engineers in the world, the people who actually have to sign off the investment in these projects, the people who actually have to go in front of certain parliamentary officials and say, I know this can be built because somebody's shown me on a proper digital way of seeing how that evidence and that level of knowledge is simplistically basic in its visualization, but it's something that non-engineers can quite easily grasp. So the virtual world becomes more and more important. See before you buy. Explore the interfaces between various components, interactions, at the different levels. So one of the examples we've been looking at and we're still working around is, it was mentioned before about the impact of the rolling stock against the track formation and how there's different changes in geometry affect how the train reacts to that. I think that's quite important, that's very important, significantly important. My challenge is, and one that we're starting to look at is, what is the effect on that on the passenger? There's a lot of push to how can you and how can the industry stretch the design challenges, because effectively it's putting pressure on certain projects, certain costs, certain elements. But understanding the passenger experience in that environment becomes even more critical. So as track engineers, you can understand even more, not only what it does to your formation, but actually what does it do to the passenger experience? Isn't it experience that passengers are going to notice? 9 times out of 10, they won't. And then materials. The reuse of materials, the alternative use for sleeper materials, the reuse of ballast. So again, this morning we heard lots about alternate types of sleeper materials, ballast utilization, and reuse of those materials. From a personal perspective, and it is a personal perspective, I don't see a lot in this area, and for me, that's an area where the rail industry needs to do a bit more exploration. It becomes in terms of how to use the materials that we have to put into the railways and make it more affordable, more acceptable, and more available. One of the colleagues this morning was talking about plastic components, and I just had this bizarre thought. We've got a 3D plastic printer, and I reflect back to my time as a permanent way engineer about 20 years ago, and I used to have 3 or 4 porter cabins or ghost stores, whatever they're called, full of plastic components, pads, clips, because that's what my section manager said I needed. So I had tons of material stored, squirreled away was the terminology that came to mind very quickly. And now I look at the use of technology and 3D printers. There'll be a point in time in the future where I actually see 3D technology will sit in the section manager's office and he can print out components that he needs because he can do it when he wants it and the technology is there. I'm seeing it in the automotive industry, we're seeing it in other parts of the industry. I can see very clearly, as materials and technology moves forward, that is something that we are going to be engaged in. And emerging technology, impact on track design, installation, maintenance, and renewal. So I mentioned 3D printing, intelligent robots. So again, Pans will beat me to it. The fact that you've got intelligent robots that now can put out on track and actually start to install the components, why is that not going to happen? And how do we as an industry work around that? The virtual system, BIM, and other types of technology, I can see that we're seeing that more and more in certain part of the building industry. I can see that being more and more translated into the railway industry, particularly as we're getting more and more data from track source and LiDAR and actually real-time data. But the one that probably interests me the most is the new forms of rolling stock, hydrogen and solar. So that's a hydrogen train that Alstom have built, and it's now running on a German network. Do we understand the change of dynamics that those type of trains will put on our infrastructure? Do we understand the loadings that those types of trains will put on our infrastructure and how they will react to different geometries, different designs, different components? And because of their nature and their utilization, are we going to be a situation where accessibility to the network becomes far less available to us? Because effectively hydrogen trains can run a lot more efficiently, a lot more easily, particularly in rural, in urban environments. And solar, it's something that's been looked at in Middle East. Can you put solar panels alongside the edge of the track and use that to power up your trains? So effectively, you don't have third rail, you have third rail, you don't have overhead line, but effectively you have large sections of solar panels along the edge of the track, which picks up the power and provides that source to the train. Implication is, how does that affect the track design? How do track designers and track maintainers understand that and design for that technology? So technology is an opportunity for change. The opportunity is you get better digital design tools, greater asset management knowledge. We've seen that in terms of some of the things that have been put to us this morning. An impact on asset use and frequency. We start to understand how the asset is being used and how that asset knowledge is being used to understand how it's going to be designed and maintained in the future. Modular development. We see modular development in S&C. How much more modular development is going to be available to us within the track industry? And that, to me, is an area that needs further evaluation and examination. And environmentally safe materials and asset management approaches. For me, the environmental side is something that we look at, we deal with, but actually, from my perspective and examination I'm seeing from the wider industry, the rail is going to have to pick up even further in terms of how we make our materials and our components and our usage far more environmentally available. But the challenge to the industry is how do we become more agile and develop the products? So this morning there was a discussion about getting through the various stages, and I think we were at level 1. I think it was the tarmac asphalt track system, and we're at level 1, and that study's been going for a number of years. To be honest, in terms of how do we as an industry and how does we as an institution try and progress those quicker, because this industry cannot rely on waiting that length of time for these components to be actually signed off into use. And the amount of time that organisations spent in getting that far, how sustainable is that? Exploring other sectors and applying methodology. So how do other linear assets manage their asset? Been looking at the water industry for quite a bit now in terms of how do they manage their linear asset. They are a critical asset that the UK has to have and has to work. If the water industry fails or a pipeline fails, you don't get your drinking water, society starts to have problems. If the rail network fails, you have a problem. We see that day in, day out, and we see the stresses and strain that it puts on, not only on the people in this room and our colleagues, but actually in terms of the wider economy of the UK. So looking at how other industries apply some of their technology, and is it transferable? And sometimes I feel we don't look at it enough, and that's from an examination of my own organisation as much as my previous life and looking at stuff. And material reuse. How much material reuse do we really use, and how much can we cascade in? So onto legacy, mindful of time. What are the legacy considerations for the future? So what is the whole life cost model input? Do we understand how the whole life cost is put together? Being very careful, I mentioned it, but with respect, we end up looking at the track design, and we end up looking at the actual design of delivering something, but actually once it's been designed and installed, what's the whole life cost of that asset? Do we really understand it, and can we explain that to the people who actually have to sign off the checks for what we deliver? Train loadings and operational changes. This is something I'm seeing more and more, and talking to colleagues in other projects. Train loadings are going up, capacity is going up, utilisation of the railway is going up, and as seen by some numbers, 30, 40 million, equating to million gross tonnes per annum. Train tonnages are going up in the UK, and that has an impact on the asset that we are designing and maintaining and looking after. And understanding how that is in a legacy, even the earliest considerations, Do we understand it? Do we know enough about it? And can we take the data that is being recorded across this network in the UK, for example, and be able to play it back at the right point in time to understand how it's tested? Business case stands for itself, but actually the business case is an interesting argument. Sometimes there's no business case for a railway scheme. If you did the pure economic model, there's no business case for it. But actually the business case is far more than just a number. It's about the societal view that it plays, and the railway engineers need to be more engaged in that to say, actually, by connecting two cities or two regions, or by putting this piece of extra track in, it's not a business case that has financial value, it's a business case that has wider operational value, wider connectivity value, and the railway engineers need to be able to explain that, because you're the ones who understand it better than anyone else. Asset maintainability and noise and vibration. We've heard a lot about that this morning and this afternoon. The asset maintainability is one that, as an industry, I'm glad to see there's technology coming out that we can start to understand through our mobile phone what our asset is doing. And I think the sooner we have that, the better we understand what the asset is available to do. Noise and vibration. The more trains we run on our network, the higher the tonnage is, the noise and vibration issue will become an issue, both for new railway lines that we are seeing in terms of HS2, East West Rail, Crossrail 2, whatever. But actually, it's going to become more of an impact on the existing network. As we run more and more trains on our existing network, the challenge for the railway engineers is how do you minimise the noise and vibration impact off that? Because our neighbours, who are not track engineers, who are not PDI members, who have got no knowledge about roads other than the train goes past their house every 30 seconds, are going to want an answer, and they're going to want an answer that is quick, easy, and efficient to deliver. Component replacement sort of picks up a bit about how can we make component placement a lot easier. The Pandal example earlier on, I think was phenomenal. In fact, can we use robots to put our stuff in, take people away from the workforce phase and put people in the better safety environments. So there's some legacy considerations, and are these really looked at in the early stage of design? From my perspective, and it's only my perspective, sometimes it's not enough. And I think as an industry, we need to engage and help people understand that, and certainly put that viewpoint back up to some of the people who are not railway engineers, but who are the ones who unfortunately have the checkbook and have to put the money in front of us to deliver what we do. And they don't understand the legacy consideration that you need to design into it because they're driven by a certain number. And finally, this is a slide I put up in front of the IC about 3 months ago. And it was the presentation was about how does engineering change our design. And I've done a bit of examination, and these 17 boxes are ones that certainly Network Rail are recognised. I think a lot of people recognise. These are the SDGs that have been signed up to from the UN, and it's something that actually a lot of companies are buying into and are saying they deliver against them. And it's a societal view about what the society demands from us as engineers, be you a track engineer, a civil, mechanical, electrical, it doesn't matter. What they demand of us from society to deliver a good society to live in, that has value, that has economic growth, that has sustainable housing, that has all the things that we want as individuals, not just as track engineers. And therefore the question is, how do we sit into this environment? And particularly in the built environment, so responsible consumption of materials, sustainable cities and communities, and how we make those more sustainable, and actually industry innovation and infrastructure. And today's whole seminar has been about innovation and research and how we put this back into the railway industry. To me, this is something that sometimes, I'm not saying we miss it on purpose, and it's a look into the future. It's something that as engineers across all the spectrum, it's something we need to become more and more aware of in terms of the future. So great technology designs in terms of, be it formation treatment, be it S&C management, whatever. I think it's fantastic technology changes, and in fact, fantastic improvements for the UK, because actually that is also something that we sell outside this island. But actually, from a more philosophical point of view, this is something I see I get challenged on, and we get challenged in the industry more and more. And as people request more and more railway lines to go between our cities and our towns, this is something they're going to ask far more understanding of. So as railway engineers, it's not just, and it is about designing a good piece of track design, it is about designing something that is maintainable and can be delivered, but actually, what is the sustainability values that we're designing into that, and how we use the materials and the components in such a manner that actually we're proving to ourselves that this is the right way of doing it. The reuse of materials is one component. How we use materials that are cascaded from other types of industries, are they available to us to use, and what technology do they have to allow us to grow our railway industry and make it a 21st, 22nd technology that everyone wants to buy into. And with that, I think, yes, thank you very much.